Assalamu alaikum. How are you girls? This is chapter 10, as I told you, Trigonometric Identities. Now it's from your book, the book that you have, Algebra 2 book. This is a very, very important chapter, as I told you. If you have any doubts, please refer to me. You want me to re-explain something, you want me to go live for a special part, just name it, any of you. I will repeat because I want to make sure that everybody understands this, because as I told you, this will not be repeated in grade 12 and it's very, very important. And the pre-calculus book is depending so much on this chapter. Identities keep repeating in the pre-calculus book, even in the calculus book, identities keep repeating. So you better make your own summary for it and try to memorize it, okay? So first of all, we took identities in lesson 4.7, proving identities before. If you remember, you just had to prove that the left side of the equation is equal to the right side of the equation. Yeah, this time it is called trigonometric identity. What's the difference? Trigonometric identity is an equation involving trigonometric functions that is true for all values of which every expression in the equation is defined. So the difference, هناك كانوا بس equations x and y. This time we have trigonometric functions in them. So for example, this is just an identity. This is a trigonometric identity. Okay, so let me say, what did they say here? They said it's true for all values of which every expression in the equation is defined. فأنا ما أجيش هنا وأقول مثلا this is not equal to this at x equals to 3. لأنه أصلا x equals to 3 it's not defined. I cannot put 3 and I cannot divide by 0. x equals to 3 خارج الستوري. لازم تكون defined. But if you simplify this, x minus 3, x plus 3, this will cancel this. This is difference of square. And the answer is x minus 3, right? X minus 3, let's say this is x plus 3. And the answer is x plus 3, okay? So this equation will always equal this equation. Whatever numbers you try, they will always equal each other. Left and right. It's always true. Always true. طيب. طبعا except x is not equal to 3, and this we all know. This is out of the story. Always true. Therefore, this is the sign that I use for therefore. It's an identity. Here, if I plug 1, 1 plus 3 is 4, 1 plus 3 is 4. Even if you try with the original function, plugging 1, you will get 1 minus 9 over 1 minus 3 equals 1 plus 3. Let's see, this is negative 8, over 1 minus 3, that is negative 2, equal to 4, and the right side is equal to 4. For any number, ما ينفعش أجرب رقم واحد وأقرر إنها identity. But this is very clear that it's an identity because x plus 3 is equal to x plus 3 after simplifying. This is a trigonometric identity or no? I can prove it's an identity with x equals to 0, but that's not going to be true with x equals to 90. Why? Let's try with x equals to 0. What is sine at 0? Remember our lovely unit circle, cosine, sine. Sine at 0 is equal to 0. So 0 equals to 1 minus. Cosine at 0 is equal to 1. Yeah, it is true. 0 is equal to 0. So I would think this is an identity. But the thing is that it has to be true for all values of which every expression in the equation is defined. That the values هنا they are defined at 90. Why not 90? Let's try sine at 90 or pi over 2. Cosine sine. Sine 90 is 1. 1 minus equals 2. Is it equal to? 1 minus cosine at 90. What is cosine at 90? Cosine at 90 is 0. Right? Cosine at 90 is 0. صح? Okay. Sine at 90 is 1. It is still true. But I will prove it's not true. طيب, let's try pi over 4, which is 45. Okay? Sine at 45 is equal to root of 2 over 2. So is root of 2 over 2. So this also says that it's an identity, but I'm still not believing. Because I know at some value at 45, this will not be true because they are equal. Pi over 2, is it equal to 1 minus? Cosine at 45 is also root of 2 over 2. There, here we go. 1 minus of 2 over 2 gave me 2 minus, which is not 1, gave me around 0.29. So 0.29, or it gave me type. So now root of 2 over 2 is not equal to 2 minus root of 2 over 2. Therefore, this is not an identity, although I proved it's an identity here and looks like an identity here, but at another number, I proved that it's not true. This is not a trigonometric identity, not a trigonometric identity, because I found some number which is pi over 4, and there are others, of course, which the functions are defined at, but the equation is not equal, or the trigonometric equation is not equal. Okay? This is the basic idea. You have to keep the unit circle in front of you while working with this chapter. It will help you a lot. This is the basic idea, that you have to understand what are identities. Now, in your books, suddenly they popped up with a lot of identities that you will have to memorize, and they are all true. Meaning, since they said they are identities, it means the left side is always equal to the right side, and we can prove that. In the video I sent you was some proving for some of them, but they are all true. The first part is called quotient identities. I will use my notes. Quotient identities, we didn't take them before, but I was trying sometimes to tell you that tan is sine over cosine. It is true. Try with your calculator sine 90. Is it equal to sine 90 over cosine 90? Sine 45 is tan 45 is equal to sine 45 over cosine 45. This is an identity. It's always true as long as cosine theta is not equal to 0. ما نجيش بقى عند اللي بتجيب لي denominator 0 واقول والله it's not an identity. اصلا the function is undefined at that part. Otherwise, this is a trigonometric identity, and it's called quotient identity. Then cotan theta is equal to the reciprocal of the tan, so it's cosine theta over sine theta, where sine theta is not equal to 0. This is all in the table in your book in page 655. You will have to memorize those, and there are reciprocal lovely identities which we took before, but we've never named them as identities. We said reciprocal functions. Now sine 1 over cosec, cosec 1 over sec, and so on. All of these, inshallah, you know. This is the easy part of it. There are very, very important Pythagorean identities. I think this was proved in the video. Now, on a unit circle, if you want just a quick hint about it, on the unit circle, if I have a point P, the point P is cosine theta, sine theta, right? And the R here is equal to 1. And we know that R squared is equal to cosine to x squared plus y squared. So R squared, which is 1, is equal to x squared, which is cosine squared x. We usually write the square here, or you need this, I'll tell you what does this mean, plus the y squared, which is sine squared y. You will find the Pythagorean identity popping. This is exactly the same as cosine theta all squared. السكوير مش للثيتا، السكوير للفانكشن كله. Okay, but usually we do not write it this way. Usually we write the square beside on the top, يعني, or exponent of the cosine, exponent of the sine. This is true, and I think the video dragged this for you and dragged this to you. This is the most popular and the most important one. Also remember tan squared theta plus 1 is equal to sec squared theta. Cotan squared theta plus 1 is equal to cosec. Remember, the c is with the c, and we started with cotan. So if I want to solve this for cotan squared, for example, I would say cosec squared minus 1. If I want to solve this for tan squared, I would say sec squared minus 1. For these three, you will have to memorize them. Also for today, you will have to memorize these three as well. Okay? I think the questions that I'm going to solve, they don't have a co-function identity, but these identities are also true. Sine 90 minus theta is always equal to cosine theta. I think we did discuss this before. And no, cosine 30 is equal to sine 60. Remember? And we proved it before. Here. Let's say I have this as 30 and this as 60, and this is, for example, let's say with letters x, y, z. If I want cosine 30, a over h, so it's x over z. And if I want sine 60, sine is opposite over hypotenuse. I'll find myself ending with x over z. This one is true, sine 90 minus theta or pi over 2 minus theta is equal to cosine, and the opposite of it, of course, cosine 90, yani if I started finding cosine 60, it will equal to, or cosine 60, it will equal to sine 30. So cosine 90 minus theta is equal to sine theta, tan 90 minus theta is equal to cotan. So tan with cotan, and of course if I wrote cotan 90 minus theta, it will equal to tan. I don't think there's application on this, but I'll get you questions, but I don't think for today. There are negative angle identities as well. I think we did deal with these before also. I tried in between telling you that for example here, cosine negative 30 is the same as cosine 30, and cosine negative 90 is the same as cosine 90. And here we spoke about even functions. Even functions are symmetric about y-axis. طيب, how can I prove that to you? Over here on the unit circle, for example, cosine 30 is root of 3 over 2, while cosine negative 30 is here, is also root of 3 over 2. Cosine 45 is root of 2 over 2. Cosine negative 45 is root of 2 over 2, and so on, because it's an even function. And if you remember the graph was symmetric. The graph of the cosine was symmetric about the y-axis, period. Graph of the cosine, it's symmetric about the y-axis. So the answer, for example, of pi is the same as the answer of negative pi. The answer, for example, for 2 pi is the same as over here, wait, this is the 2 pi, it's the same. The answer, for example, whatever, the answer over here always is equal to the answer over there, because it's symmetric about the y-axis. Unlike the sine graph, okay, over here if you try, let's try sine at 30 is half. So sine 30 is half, and sine negative 30 over here is negative half. How can I make half equal to negative half? I have to add a negative, right? That's why there is this negative. So sine negative theta, يعني كأني بقول sine negative 30 is equal to sine 30, but I have to put a minus sign to make them equal عشان يبقى half, or here negative half is equal to negative half. Anyways, this is just to understand the graph of the sine graph is not symmetric about the y-axis. بالعكس, it's an odd function, symmetric about the origin. Here, sine pi over 2 is 1, while sine negative pi over 2 is negative 1. To make them equal, we have to add a negative to the identity. Okay? And the same for tan and negative tan. Let's try tan at 45. Tan at 45 is equal to, remember tan is equal to sine over cosine. Okay, so tan 45 is equal to 1. While tan negative 45, here's the tan is negative in this quadrant. It's negative root of 2 over 2 over root of 2 over 2. The answer is negative 1. How can I make tan negative 45 equal to tan 45? While this is negative 1 and this is 1, I have to add a negative here, and this is this negative. So again, I know it's too much for today. You can pause and rewatch. Anyways, this is odd function or symmetric about the origin. This is odd function or symmetric about the origin. This is even function, symmetric about the y-axis. So here there's no problem. As I said, in this machine, putting a negative or putting the number as positive, you will get the same answer. لكن هنا لا. This is just to clarify the negative angle identities. Okay, I will stop, send another video for solving. Bye.